Excuse me, sir, you are not audible.
Hello, hello.
Yes, sir.
Am I audible
Yes,
now?
yes, sir,
Okay,
you
so
are audible now.
okay. There was some internet issues. Okay, I'm very sorry. Okay, let me just share it once again. Okay, so is it visible now? Screen is visible now.
Yes, sir.
Fine, fine. Okay. See, so this theorem, let me recall once again what we had discussed yesterday. We had considered two subspaces, W1 and W2. Both are finite dimension. Okay, W1 and W2 are finite dimensional subspaces of a vector space V, such that it satisfies this condition. We have assumed this condition is W1 intersection W2 is 0, right? Then we have proved that dimension of W1 plus W2 is same as dimension of W1 plus dimension of W2. This is what we have proved. Okay, so as we know that W1 and W2 are finite dimension, right? So finite dimension means what? Dimension means it is connected to basis. Because the definition of the dimension is the number of elements in the basis is called a dimension. So therefore, basis should exist because W1 and W2 are finite dimension. So it is said that W1 and W2 are finite dimension. So therefore, we can assume that two dimension. One is for W1 and other is for W2. Okay. So we have assumed that alpha 1, alpha 2, etc. alpha m. It's a basis for W1, and similarly we took beta 1, beta 2, etc. beta n. It is a basis for W2. Okay. So there are two bases. And then we assume that both are finite, so we'll assume that, so from this observation we have dimension of w1 is m, and then dimension of w2 is n. So now if I add these two directly, right, w1, dimension of w1 plus dimension of w2, this is nothing but m plus n. So this is dimension of w1 plus dimension of w2 is m plus n, but I have to prove that this is equal to dimension of w1 plus w2. If that is so, then we are done. That is what that is what we have done. So we have to now prove that dimension of w1 plus w2 is same as m plus n. I mean, if I add these two, okay, a and b, if I add a union b, okay, I should get this as a basis. Okay, so we denote that as a b prime or b dash. So b dash is nothing but we have taken alpha 1, alpha 2 to alpha m, and then beta 1, beta 2 to beta n. Okay, it is a basis for W1 plus W2. So it is a basis for W1 plus W2. So basis means what? It should satisfy two conditions. One is that it should be a linearly independent set and it should be a spanning set. Okay. So linearly independent set and then a spanning set. If we are done these two, then we have proved that B prime is basis. So first, what we had considered it is a linearly independent set. Means we have to prove that it is a linearly independent set. So to prove the linearly independent, so we consider the combination, linear combination, and then we'll prove that all the scalars C1, C2, etc. Cm, and then D1, D2, etc. Dn must be zero. So these two combinations, so I'm writing this the first combination to C1 to Cm into alpha m is U, I'm taking as U, and then the other combination as V. Okay, and it is clear that this alpha 1, alpha 2, etc. alpha m, these are the vectors which belongs to W1. So U must belongs to W1. And beta 1, beta 2, etc. beta n are the vectors in W2. So therefore this combination V must be in W2. So therefore U plus V equal to 0, where U belongs to W1 and then V belongs to W2. Okay, so U plus V equal to 0, then we have written U equal to minus V. Okay, we already know that U belongs to W1, but whereas V belongs to W2, so there's linear, there something constant times V is also belongs to W2. So here the constant is minus 1. So therefore U belongs to W2. So U already belongs to W1, but again from this observation it is W2. So therefore U belongs to W1 intersection W2. So we are given that W1 intersection W2 is 0. So therefore that this will be 0. U belongs to W1 intersection W2, but W1 intersection W2 has only one element which is 0. So which implies that U must be 0. So since U is equal to minus V, then V is also 0. So U and V are 0 separately. Now what is given? Okay, so what we have proved that U equal to 0. U equal to 0 means what? C1 alpha 1 plus C2 alpha 2 plus etc. plus Cm alpha m. This combination is 0. Okay, if this combination is 0, and we already know that alpha 1 alpha 2 etc. alpha m is a basis for W1. If it is a basis means it is obviously linearly independent. So our only aim is that we have proved that U equal to 0, V equal to 0, which implies that we are already done. So therefore B prime is linearly independent is straightforward. Okay, so B prime is linearly independent is straightforward. Now we have to show that that B prime is a spanning set. So spanning set means what? Whatever vector I take in W1 plus W2, that should be expressed as linear combination of the vectors in W1 plus W2. Okay, I take something in W1 plus W2, that should be expressed as linear combination of vectors in that. Then we are done. So x is in W1, but x is in W1. W1 is nothing but it is having a vectors alpha 1 to alpha m. So therefore x should be expressed as linear combination of those vectors. Similarly, y, if I take y is in W2, then W2 is having a vectors beta 1 to beta m. So that should express as linear combination of these vectors. So then when I add z equal to x plus y, this will be C1 to C1 alpha n, C1 alpha 1, etc. Cm alpha m2 dn beta n. So this is a linear combination of vectors in W1 plus W2. So therefore it is a spanning set. So from this analysis, yesterday we have proved that it is a basis, and then basis means the number of elements in that, it's called a dimension. So therefore the number of elements is m and then n. So that is m plus n. So then we have proved that dimension of W1 plus W2 is same as dimension of W1 plus dimension of W2. Now we'll move further. This is what we have discussed yesterday. I have written this. This is the more general means next theorem. We are not imposing any conditions. Now we'll remove that condition and we are going to prove the theorem. Okay. So we'll just write that. Am I audible to everyone?
Yes, sir.
Okay. So we'll prove the next theorem. Okay. If W1 and W2 are, this condition remains same. Okay. If W1 and W2 are finite dimensional subspaces. If W1 and W2 are finite dimensional subspaces, W1 and W2 are finite dimensional subspaces of a vector space V. W1 and W2 are finite dimensional subspaces of a vector space V. Then W1 plus W2. Okay, I think this is straightforward. Okay, this condition we don't want. It means then find W1 W2 are finite dimensional. That is okay. Okay, so then we'll write this condition. Okay, dimension of W1 plus W2 intersection. Okay, sorry, dimension of W1 intersection W2 is same as dimension of W1 plus dimension of W2. Or this can be separated. This can be subtracted also. So we can write dimension of W1 plus W2 is same as dimension of W1 plus dimension of W2. Means it will be like the previous result only. Dimension of W1 plus W2 will be same as dimension of W1 plus dimension of subtracting with this dimension. Okay, so there are some books they write. Okay, anyway, that's the same thing, similar thing. Let us now quickly see the proof of this. Okay, so one thing is very clear, the same analysis, since W1 and W2 are finite dimensional, okay, those two are finite dimensional, so you can take two subspaces. For W1, you can take two bases, one you can take for W1 and other we can take it for W2, okay, because those two are finite dimension. Since W1 and W2 are finite dimension, so we can take two bases. So let us write that observation first. Since W1 and W2 are finite dimensional, W1 and W2 are finite dimensional. So we can take two bases. Okay, with the finite entry. Okay, we can take two bases with finite elements because finite dimension. Of course, that is not required because we are dealing with only finite dimension only. So one more thing that here we need something for W1 intersection W2 also. Okay, since W1 and W2 are finite dimensional, so it is very clear that W1 intersection W2 must be also finite dimensional. Okay, W1 W2 are finite dimensional, so W1 intersection W2 and W1 plus W2 are also must be finite dimensional. are also finite dimension. Are also finite dimensional. Okay, now we have to choose something, for the basis. So one more thing is that we can choose some basis for w1 intersection w2 also, as well as we can choose a basis for w1 intersection w2, but at least one of them must be proved as a basis. Suppose you take some vectors, some vectors for w1 plus w2, then we have to prove that that is a basis, or we have to prove it for this is a basis. But now we'll assume for this and we'll prove it for this, because w1 and w2 are finite dimensional, so we can take something and their intersection also we can say that it is a finite dimension. That is not an issue. So now we are going to take that. Now we'll take two bases, one for w1 and other for w2. Okay, we'll take two bases. Let alpha 1, alpha 2 to alpha k, and beta 1, beta 2 to beta m. Okay, be a basis, be a basis for w1. I'll tell you why we have taken only why, because in earlier case we have taken only alpha 1 to alpha m, not alpha 1 to alpha k and then beta 1 to beta, not like the combination of the vectors. But I'll tell you the reason, because we are going to talk about an intersection, so we'll take at least one of them are common in both the things. Okay, and there are some different vectors are also there. That is the aim. That is an idea. Okay, and similarly we take alpha 1, alpha 2, the same vectors exist in w2 also, but we'll change this thing. We'll take gamma 1, gamma 2, gamma n, be a basis for w2. So since, because of the dimension, finite dimension, okay, because of the dimension we have taken this. Okay, because of finite dimension. Okay, we have taken this. Now you see, this is the vector alpha 1, alpha 2 to alpha k, beta 1 to beta m. These are the vectors in W1. Okay, it is a basis. These are the vectors. And similarly, alpha 1 to alpha k, gamma 1 to gamma n are the vectors in W2. So basis in W2. So intersection will be what? Alpha 1 to alpha k, because the common vectors are alpha 1 to alpha k. That is my aim. So I want to have something like that. So I just assume that. So now from this observation, one can say that alpha 1, alpha 2, etc., alpha k be a basis for w1 intersection w2. Okay, alpha 1 to alpha k be a basis for w1 intersection w2. So okay, it is a basis for w1 intersection w2. So I can say that therefore, okay, I'll just write, therefore dimension of w1 intersection w2 is just k, because there are only k entries are there, alpha 1 to alpha k. Dimension of w1 intersection w2 is k. But by the previous these things, w1 w2 basis, I can also write separately dimension of w1, also I can write dimension of w2. Okay, so you see the dimension of w1 is what? Alpha 1 to alpha k, one vector, and beta 1 to beta m is another vector. So w1 dimension is k plus m. Okay, and then for w2 dimension is alpha 1 to alpha k, gamma 1 to gamma n, so k plus n. Okay, dimension of w1 is k plus m and dimension of w2 is k plus n. Okay, so these three observations we just made it because it is given that w1 and w2 are finite dimensional subspaces. Okay, now we'll go back that what we had now. So we have this dimension of w1 plus dimension of w2 minus dimension of w1 intersection w2. If I do this, this should be what? Dimension of w1 is k plus m, dimension of W1 is k plus m, plus dimension of W2 is k plus n, minus dimension of W1 intersection W2 is k. 1k we can just cancels out. So this is nothing but k plus m plus n. This is what we have to prove, that this we have to prove that this is same as dimension of W1 plus W2. This is what we have to prove. Okay, this is what we have to prove. This is what we have to prove. Okay, am I audible to everyone?
Yes, sir.
Okay, good. So we have to prove that dimension of W1 plus W2 is k plus m plus n, because we know dimension of W1, we know dimension of W2, we know dimension of W1 intersection W2, and after adding all these things, we are getting k plus m plus n. So now I have to prove that this is equal to dimension of W1 plus W2, because these two are equal. That is what we have to prove. So if these two are equals, means this should be same as k plus m plus n. Okay, now we'll try that. We want to prove that. We want to prove that. We want to prove that dimension of W1 plus W2, dimension of W1 plus W2 will be same as k plus m plus n. We want to prove that dimension of W1 plus W2 will be same as k plus m plus n. Okay, so dimension of W1 plus W2 should be having elements k plus m plus n. So therefore we have to consider the vectors k, m, n. Okay, so to consider that, let us consider that. Let us consider that. Okay, let us consider that. Let us give some notation. B is equal to alpha 1, alpha 2 to alpha k. Okay, beta 1, beta 2 to beta k, gamma 1, gamma 1, gamma 2 to gamma k. We'll consider this. Okay, this set. So because now, oh sorry, we have to write m plus n. So let us now, we don't write beta k. So let us give, okay, because we are already considered that beta 1 to beta m only. So we'll write here this is beta m and this is beta n. So that this dimension will be k plus m plus n. If we prove that it is a basis. Okay, now because I want to prove that it is k plus m plus n, okay, dimension, so I am considering this vector. Now I want to prove this is a basis. If I prove this is a basis, then dimension is k plus m plus n. Okay, so that is we have to prove that. We have to prove that. We have to prove that. Okay, we have to prove that B is a basis. We have to prove that B is a basis. Again, what was the thing? There are two things. If you want to prove it is a basis, first you have to show that it is a spanning set or linearly independent. Okay, whatever you want, write, you write. B is a spanning set. Spanning set, and B is linearly independent. Okay, there are two things. B is a spanning set, we have to prove that, and B is linearly independent. Okay, the conditions we have to prove. See, the spanning set would be very quick, because that is, once again, that is the same analysis what we had done earlier. Spanning set means what? Suppose you take suppose you take z belongs to w1 plus w2. Suppose you take w belongs to w1, z belongs to w1 plus w2. Then we have to say, suppose, okay, if z belongs to w1 plus w2, then there are vectors x is in w1, same thing only, and then y is in w2. Okay, such that z can be expressed as x plus y. So that x plus y is equal to this. Okay, if I take x and y are w1, so let me just show you that. So W1 will be what? These are the vectors alpha 1 to alpha k, beta n to beta m. W2 will be what? Alpha 1 to alpha k, gamma 1 to gamma k. So there are intersections are there. There is no problem. So then if you take x belongs to this means x should be expressed as linear combination of vectors of alpha 1 to beta m, and then y should be expressed as linear combination of alpha k, alpha 1 to gamma n. So therefore it is straightforward. So instead I don't want to write. So therefore z can be expressed as x plus y. Then this should belongs to w1 plus w2. So therefore spanning set is okay. This implies that you can write z is nothing but linear combination of those vectors. So spanning set B is a spanning set. So B must be a spanning set. So there is no problem with that. Now, only thing is that we are concerning about linearly independent, okay? Because linearly independent means you should be able to show that all these scalars, okay, whatever scalars you consider, C1 to Cn, whatever D1 to D1, whatever scalars you consider, that must goes to zero. That is the only thing we have to show. So we are now concerning about only the linearly independent. So now we have to show that we have to show that B is linearly independent. Okay, we have to show that B is linearly independent. Okay, okay. So linearly independent means you have to consider the first combination. B is nothing but what? Alpha 1 to alpha k, beta 1 to beta m, gamma 1 to gamma n. Okay, so we have to first consider the linear combination. Okay, so we have to show that B is linearly independent. At the combination, we consider the linear combination. We consider the linear combination. So whatever combination we'll take, okay, x scalar x y z will take. Okay, so it's not a problem. Or c d whatever you want to take, you take x1 alpha 1 plus x2 alpha 2 plus, okay, first k vectors are there, so xk alpha k plus y1 beta 1 plus etc plus what was that ym ym, so beta 1 to beta m. Okay, so then ym beta m, so this must be ym beta m, and then there are vectors gamma 1 to gamma n. So similarly this is, let us take z1 gamma 1 plus etc. This is z and gamma n must be 0. Okay, so we have to first consider the combination, linear combination. So let us give, instead of writing these things, x1 alpha 1, x2 alpha 2, etc., let us give some simple notation for this. Okay, so for this vector we'll give 1, and for this vector and then this vectors, let us give some simple notation. In terms of summation we'll give, because these are the sum. Okay, this first we give xi into alpha I, okay, plus summation yj beta j plus summation z, let us give r, okay, z r gamma r equal to 0. Or earlier we have considered u plus v equal to 0. That also you can consider. U plus v plus w is equal to 0. That also you can consider. Okay. U plus v plus w is equal to, also you can consider. That is not an issue. Okay. So summation xi into alpha I plus summation yj into beta j plus summation zr into gamma r. And then you know that I runs from 1 to k, j runs from 1 to m, gamma runs from r runs from 1 to n. That is what this summation over I. That also you can write. That is okay. Okay, now we'll do we are only but little bit different. Okay, so now this is, you say that summation over xi alpha I plus summation over yj beta j, which is same as minus summation over r z r gamma r. But z r gamma r is what? Okay, z r gamma r is because gamma is there. Let us go back this. See, gamma is there in this basis. Gamma is there in W2. Gamma 1, gamma 2, gamma n. Alpha 1 to alpha k. Both are in W2. So gamma 1 to gamma n should be in W2. Okay, it is in W2 only. So this is W2. So since summation over is in W2. Okay. But we also see that, okay, we also phi are the vectors in W1. Beta j also vectors in W1, but z r gamma r I am writing this is equal to this. So this must belongs to, okay, or you can say this must belongs to W1 also, because alpha and beta j are the vectors in W1. So if I am writing something is a combination of that, that should belongs to the same set only. So from this observation, one can say that summation over z r into gamma r should belongs to W1 intersection W2. And W1 intersection W2 having the vectors, let us now see the once again. Okay, W1 intersection W2, what are the vectors? This one thing in that, then I should able to write this as a combination of the vectors in this. So therefore this shows that, okay, it follows that summation over z r gamma r as linear combination of the vectors in W1 intersection W2. So that can be expressed as some Ca into alpha I. Okay, and we have already shown that alpha this one W1 intersection W2 is a basis, or you can say W1 this one W this ZR into gamma R should belongs to W1 as well as in W2 will be 0 for all the scalars are also 0, because if it is a basis means it is a linearly independent also. So therefore summation over ZR gamma R will be same as summation over Ca alpha I. It should be 0. Okay, for all values of Ca and ZR is also 0. So Ca is also 0 and ZR is also 0. So if this is 0, okay, if this expression is 0, then I can say that this is also 0. So it implies that I can say that summation over xi alpha I plus summation over yj beta j is also 0. Okay, since alpha I and alpha I beta j are basis for W1, since W1 is a basis, W1 basis, which implies that all the scalar xi is also 0 and then yj is also 0. So therefore yj is equal to 0, zr equal to 0. This is true for all values of I, j, r. So which implies that the set B is linearly independent. Okay, which implies that the set B is linearly independent. Okay, so B spanning set just B really independent set. So therefore, the whatever B we have considered, so B is a basis. B is a spanning set, and B is linearly independent set. So implies that B is a basis. B is a basis. Okay. So B is a basis means the dimension of B or the dimension of W1 plus W2 is nothing but what are the elements we have? Number of elements in the basis B. We have K plus M plus N. So this is same as K plus M plus N. Okay, so therefore I can say that dimension of W1 plus W2 will be same as dimension of W1 dimension of W minus dimension of W1 intersection W2. Okay, so this will be very much useful when we are given only that dimension of W1 and dimension of W2. If we are given okay, dimension of these two W1, okay, so W1 is some basis is given, that W2 is another basis is given. Only these two informations are there. That is what the theorem also says. Okay, you have only these two informations: W1 which has some vectors, W2 which has another vectors. Okay, so those two are basis. That means those two have a finite dimension. So W1 will be a finite dimensional, W2 will be a finite dimensional. And it is true that W1 plus W2 also finite dimensional because we are adding both the things. We are adding both the things, so it will be also finite dimensional. But the formula will be different. It is not just suppose you are given something like that. So okay, suppose we'll give a counter example. We'll give a dimension of W1 is let's say 2, and then dimension of W2 let's say 4. Okay, and it is not that dimension of W1 intersection W2 will be always 0. There will be some dimension also. If it is 0, okay, if the conclusion from the previous theorems, if dimension of W1 intersection W2 is 0, there is nothing is there 0, then I can say that dimension of W1 plus W2 will be 6 only. Directly I can add these two, just 6 vectors. If not, if this is not true, dimension of W1 intersection W2 is not 0. Okay, let us say this vectors is, let's say, something, at least one is there. Then the dimension of W1 plus W2 is not same as 6. It should be 2 plus 6, 2 plus 4 minus that. That is what you will get. Okay, suppose this is not the case. Let us say this is 2. So in that case, you won't get this. This is you will get as a 4. This is the dimension. So this will be, I think, very useful. Maybe when you go for the the higher studies or MTech, if you go for MTech is signal processing or MTech is in image processing, maybe you will more analyze, more focus, more analyze. You will study in deep, the basic properties of this thing, dimension. And then suppose you are given it's not only vectors, means it's not only these things you are given only the vectors. It can be any in terms of your transformation also. A transformation can be expressed in terms of the matrices. Matrices can be expressed in terms of system of equations. Everything should be connected. So from there it might be very much useful. So if you are given only two bases, and how do you analyze the basis for the W1 plus W2, and how do you analyze the basis for and W1 intersection W2, and then based on the dimension of W1 intersection W2, whether it is 0 or if it is having some finite number, so based on that the complete analysis will be changed. So there it must be might be useful there. So till this dimension and this subspaces and then basis, all this part is over. Now, as I told you yesterday, also I told you. Now we should do some problems related to that. I will do tomorrow. Will problem something related to subspaces. First, let us do some problem subspaces, and then we'll come to dimension. And then we also see that whether we can give some counter example for this also. Dimension of W1 plus W2, where it is actually used, something like that. We'll try to look at some numerical computation, some examples. Okay, so that's what we do. Okay, so we have what we have done till now. uh, this one, solution of the matrix, rank of a matrix, elimination, vector spaces, subspaces, linearly independent, dependent, and basis and dimension. Okay, am I audible to everyone? Hello.
Yes, sir.
One thing we are going to have soon, maybe probably next week, because as you know the system pattern, so we are going to have four quizzes, right? Four quizzes and then midterm exam and then final exam. So you know this pattern already, right? So probably next week we'll have a first quiz, and a quiz will be conducted in that Google Classroom. That the Google Meet share, that will be link will be shared, and you'll have to just everything will be MCQ type only. You'll have to just click the answer. That's it. So probably next week you'll be ready for your first quiz exam, and it will be of having the syllabus whatever we have done till today. Maybe problems will be discussed. Maybe coming days also some problems I will do related to that. So the portion is still whatever we have discussed: system of equations, rank of a matrix, Gauss elimination method, vector spaces, subspaces, basis, dimension. Till this, okay, the syllabus for your first quiz exam. So that will be of having a 10 marks. Okay, if you are not able to access this Google Classroom, just till now, I mean, so some of them I think might not have registered or joined in that. So I request all of you join in that link. And then if you face any problem, anything such, just please let me know so that I can add you in personally. Also, I can include your Gmail ID, so it will be added automatically. And do it as early as possible. Next week, you be ready. Maybe next class, I will announce the date also. Date of the exam also it will be announced. And during the lectures time only, the exams will be taken. And next lecture I will do some problems related to that. I'll do some one or two problems in the I'll discuss. Okay, one problem I'll do for subspaces, and then one or two problems I'll do it for the dimensions also. Okay, how to find the dimensions and that. Of course, instead of going for this specific thing, we can go for a matrix approach also. That will be discussed in coming classes. Is it okay?
Sir, can you tell the syllabus once again?
Syllabus is whatever we have discussed till today, and then some problems will be discussed in next class. So till today and then related problems.
Okay, sir.
Okay, so from the starting to till today, and then some related problems. Related problems means basis, dimension, vector space, subspaces. I think I have given some problems in that tutorial sheet also. Just try to work out those problems also. So tomorrow we do not have class. We have a class on Friday. So rest of some problems I'll discuss on Friday. Friday and Saturday we don't have class. So Friday will be the. So next week probably Friday tomorrow day after tomorrow I will announce the date.